seeing things like a hurricane develop in its earliest phases, getting a much better idea of its strength than we can from flying 1 or 2 planes through it. We can map the entire surface effect of a tropical storm.
The ISS Rapid Scat is a mission to bring a payload to the International Space Station, and from there we will observe the Earth's oceans and be able to map the speed and direction of winds near the surface.
Rapid Scat is a scatterometer. It's a radar. It sends out little bits of energy towards Earth's surface that then get reflected back.
If the ocean is flat, most of that energy from the radar just scatters away.
The stronger the wind, the rougher the surface will be, the more energy will be returned to the radar, and then we can convert that energy into a measurement of the wind.
And that'll help us do things like track and predict severe storms, and also learn about the ocean-atmospheric interface.
Especially over the tropical regions, which are of great interest to the United States, because most of the tropical hurricanes that hit the United States come from those regions.
We're launching on a SpaceX Falcon 9 rocket.
The Dragon capsule separates from the Falcon 9 in orbit.
And after orbiting Earth a couple of times, the International Space Station robotic arm reaches out and gently grabs the Dragon as the Dragon, slowly approaches the ISS.
About 2 days later, ground controllers bring the robot arm over.
The robotic arm then reaches into the trunk and grabs the instrument and plugs that onto the International Space Station.
And everything mates robotically. We hook these pieces together and then we get to stay on the outside of the space station for a couple of years. The space station came and asked what relatively inexpensive payloads we could put up on the space station.
We had this hardware sitting there doing nothing, collecting dust for the last 13 years. We might as well try to put it to use.
What if we took some of the existing hardware and tried to fly it in the simplest way possible?
We've put them through extensive testing, electrically tested them, vibration tables, thermal vacuum chambers.
And that leftover hardware meant that we got to save about 80% of the cost in terms of being able to reuse the hardware instead of building new.
And we've added the necessary adjustments needed for this new orbiting platform that we'll be on.
The space station is built out. We know what the external capabilities are. We know we can put science instruments in different places.
We're taking something with a very small team, a very small budget, and a very short schedule, and turning it into something with very real science value.
The global coverage of the Earth is probably right now one of the greatest priorities that people should have in mind when they think about the importance of the space program.
The Earth is a very dynamic, very complex system. And because of the role that winds play, it's a fundamental part of that whole story.
And we need people's awareness and understanding of the importance of NASA's mission to help understand how our climate is changing.
thumb in there, be careful, because you don't want the wave guide to hit it. Just to make sure. Actually, it is spinning pretty straight. Yeah, no issues there. Have to cut this tie then, right? No. It's just from this one. Just up there. And it's mated, right? Yeah. So you celebrate on those.
Still put the screws in and hold it and then take them out on the side.
That's what we should do. We should put those two and not torque them at this time. Back here is going to be difficult. You just want to make sure you don't wipe the paint. The black stripe goes across here.
Position on this project?
Sure. My name is Howard Eisen. I'm the project manager of the ISS Rapid Scat mission.
Great. Could you tell us what Rapid Scat?
Rapid Scat is a payload that we put on the outside of the Columbus module on the International Space Station. And from there, it measures ocean, wind, speed, and direction.
Great. And how does this NASA's Earth Science Initiative?
So NASA takes a lot of different measurements in different wavelengths, different colors, with different kinds of instruments to understand what's going on with our planet. Some of those measurements are over land, some are over ocean, and we're just one important component of that. We tell you about wind and about wind over the ocean in particular, and therefore what the interplay is between wave and wind and how that involves nutrient mixing and how winds build up over large swaths of ocean, how they interact with coastlines. We also are very important for understanding tropical storms because we can see what's happening down at the surface across the entire swath of a tropical storm.
Do you want to, from the data gathered from Rapid Scat?
Sure. So just like the rest of the Earth observing instruments, we need to be able to piece together information about how the Earth interacts. And wind is one important component of that. And in particular, we're getting wind over the ocean where large winds can develop, where tropical storms can develop. And also we understand a lot more about how wind interacts with waves and how that involves nutrient mixing and therefore how healthy the ocean is.
Excellent. Nice. Thank you. Yes. Can you talk about that journey a little bit?
Sure. So unlike most missions, we are not a dedicated spacecraft. We're a payload that sits on the outside of the space station. We launch from Florida on a SpaceX Falcon 9 rocket inside the trunk of what's called the Dragon cargo resupply vehicle. The Dragon has a cylindrical section on the back that supports the solar panels. Inside is our payload mounted in two pieces. When we get to the space station, the robotic arms are controlled from the ground. They reach inside and grab the two pieces one at a time and mount them to the Columbus module.
Awesome. Schedule and under budget, basically.
Sure. Your Rapid Scat's different from most missions. We didn't start with just a pure science objective and develop a payload around it. We started with leftover hardware and this target of opportunity in that there was a launch available to us. There was an open space on this mission, SpaceX 4, and we had hardware that was 10 to 15 years old that was left over from the last big scatterometer that we built. We pulled that hardware out of storage, we checked it out, it looked good, we said we can build a payload around it.
I'm Stacy Boland. I'm the Project Systems Engineer for ISS Rapid Scat.
Great. So tell us, what is Rapid Scat?
Rapid Scat is a radar scatterometer. It's a payload that's going to go on the space station, and it's going to measure ocean wind speed and direction.
Great. And can you tell us ISS and how it gets installed? That'll start that.
Rapid Scat launches as two separate payloads in the trunk of the Dragon capsule on top of a SpaceX Falcon 9 launch vehicle. Once the Falcon 9 gets into orbit, the Dragon capsule is released. It then maneuvers to get into position to be captured by the space station's robotic arm. That robotic arm then berths the capsule to the space station, and then our payloads are robotically extracted and installed on the Columbus module.
Great. exciting.
RapidScat's going to provide ocean wind speed and direction data, and that'll help us improve weather forecasts. It helps us learn about the ocean-atmosphere interface. So one of the things that I'm really excited about from RapidScat is it'll help us improve the forecasting of severe storms. And so I grew up on the Gulf Coast, and I remember watching the weather forecasts. And you know those little arrows you see showing you the wind speed and the hurricane? Well, that's what we do. And by getting more of that data and better data, we'll help you know whether you really do need to evacuate, whether that storm's going to get more intense and where it's going. And so I'm really excited to be playing a part in helping us get better at forecasting those severe storms.
Great. And along those lines.
So RapidScat is going to be one of 5 Earth missions launching in 2014. So this is a fantastic year for Earth science at NASA. And NASA Earth Science is looking to try to understand the entire Earth as a system. And RapidScat fits that perfectly. We are measuring the ocean-atmosphere interface. After all, that is what a wave is. And so by measuring ocean wind speed and direction, we'll be providing a very valuable data stream. But it is just one part of what NASA Earth Science is doing, even this year.
What's gets made out of, that story?
So RapidScat's a bit of a scrappy mission. Times are really tight budget-wise, not just for us as families, but also for us as a nation. So NASA's budget's been really tight, which has led us to be quite creative. And in fact, we were able to use parts left over from a satellite that launched in 1999 to build this new payload. And so by using those existing parts, and then finding commercial parts off the shelf that we could buy to interface with the space station, we were able to do this mission for a small fraction of what a normal space mission usually costs. And we will be providing big value science data for a very, very good value.
move it around.
Okay, we can work on the side channels now too. Oh, that does not feel good.
Yeah, they're not lining up very well.
Here, assembly, keep going.
Yeah.
Keep going.
Keep going.
This is all the torques. What this list is for.
Okay.
So you have to find the top assembly one, the 110022. Should be making your way now.
I'm going to tilt back down and put the side screws in.
We're ready for side channels now?
Okay.
So is this the last install before flight?
It's backwards, but it works.
Yeah, you only need four units.
So cut section to 4 plus or minus a quarter inch, but we always do.
So your note comes like 5 steps after you cut it.
Not a flight thing I'm doing. Thank you for that, Ben.
Anything to help.
Oh, and I have to do this to each one of these boxes.
The notes or just?
So this is the
One and
replacement for
two?
the torque sheet. So you know the torque sheet?
Yeah, I
So
understand.
instead of a torque sheet,
What is one is? The screw one and two?
screw number 1, screw number 2.
Okay.
Yeah.
Okay.
Yeah.
Okay.
Yeah, but if there's not enough room to get their leg in there, it's not a pinch hazard.
Let me see from here.
Their paw or something. If it's not a pinch hazard, it's fine. She knows. She knows we're kidding. We gotta take those labels off. We'll do it. Yes.
set. Look pretty good. Looks like we're ready to go in that. Yes. That's exactly what I was thinking. Make it look kind of fancy. Like this.
then we'd be cool. But this fits that one? Yeah. We got a 3/8 on it, it'd be in great shape.
Okay. It's one of those things that the safety panel has realized, that's,
And I mean, they're going to be upright, so there shouldn't be any problem. Come a long way since our first days of trying to make this stuff. Remember? What do we do?